We used to do this so a sequence. A sequence is simply just a list of numbers in a certain order. So it's a list of numbers in a certain order. And because this section we're only doing these arithmetic sequences, we're going to have kind of a limit to what rule we can have to get from one to the next. But if we were to have the sequence that starts out with a 1, so we have a 1 and then a 2 and then a 4, the next number would have to be 8. And then the next number would be, I heard it from somebody, 16 and then 32. And kind of the rule that applies to that sequence is to get from one number to the next, you always times 2. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, and so on. Good? So we're going to have numbers that typically are going to have a rule that kind of goes from one to the next and so on. Now each number in the sequence, instead of saying this 1 right here is the first number and 2 is the second number and 4 is the third number, they just call them terms. So maybe pick a different color than that, but we'll say this one right here is technically it's the first term, and 2 is going to be the second term. And I'm kind of running out of space, so maybe I'll jump down here to the 16, and we'll say the 16 is the which term?
16.
Nope, it's just going to be the third. Oh, I can see where you'd say 16, though, because my example is kind of a little bad, because my first term is 1, my second term is 2. But 4, oh, yep, messed that up, didn't I?
It's a fifth.
This is a fifth. So 4 is going to be the third term. That's kind of where I was going, thinking that I should have wrote that in after the 1 and the 2. But when we talk about a term that something is, we're just saying which number in the sequence, which number in the list it is. Is that fair? Okay. So call them terms. So each term, B, then a term is going to be each number in a sequence. We just refer to those as terms. We okay? Yep. Now an arithmetic sequence, or an arithmetic sequence, maybe say it that way, is going to be a sequence where you get from term to term, or you get from number to number by, I'm going to say, adding a common difference. So adding, and I'm going to put common difference in parentheses. Take that back in quotation marks. So I'm adding this common difference. And if you notice down in letter D, I have common difference. I'm just going to write in a lowercase d. That common difference, that what you add to get from one term to the next, they're just going to call D. So if I have this example 2 sequence to get from a 1, struggling today. To get from a 1 to a 4, I'm adding 3, 4 to 7, you add 3. So the next two numbers have to be 10 and 13. And we could, if you wanted to, say for those, the D is going to be 3. So we're adding 3 every time. That next sequence, so example 3, I have 10, 8, 6, 4, and 2. So those now have a common difference of what number? Negative 2, because I'm adding a negative 2. Really, I'm kind of subtracting 2, but you agree adding a negative 2 is the same as subtracting 2? So your sequence could be going down to smaller numbers as it goes. If it does that, then your common difference is going to be a negative number. You're adding a negative, you're getting smaller. Fair? Okay. So a common difference then is what you add to get from one term, or one number in the sequence, to the next. Or maybe throw a term on there. So what you add to get from one term, one number, to the next term or the next number in the sequence. If you wanted to, you could say this. If you're trying to find D, to find this 3, do you agree I could do 10 minus 7? Or I could do 7 minus 4 or 4 minus 1. To find the difference, I take a number and subtract the number that's in front of it. Yes? So if you wanted to, you could say the common difference D equals any term or any number in the sequence minus the term before it. And that actually works for that third example as well. If we wanted to find the -2, the common difference for this one, you take any term like 4 and subtract the number before it. So 4 minus 6 gives me a -2, or 8 minus 10 gives me a -2. So it works for either kinds of those sequences, going up or going down. Yes? Cool. Okay, so then this example 4 has a common difference of, ooh, something is not cool in example 4. So this one here doesn't have a common difference. So does it fit with one of these arithmetic sequences? Nope. So this one here, you could say it's not arithmetic. Because if you do this here, like the 4 minus 1 gives me a 3, and this there, the 16 minus 9 gives me a 5. You know, so we don't have a common difference, so it's not an arithmetic sequence. Fair enough on those. All right, turn the page. So function notation. We're trying to come up with what's a nice way to write this. Because to go on and say the first term is 2, the second term is 5, the third term is 8, just takes a lot of writing. So you come up with a shorter way to do it. And this is how they do it. So instead of saying, I guess we could, if you wanted to, you could write in like the first term. But instead, they'll do like a capital A and then a lowercase 1. And sometimes you'll see them use other letters instead of an A, like a T sub 1 or a, I don't know, M sub 1 or something like that. But the key is really that sub 1 means that that's the first term. So the second one here, you could write out second term, or you could say A sub 2 technically, but because it's a subscript, it's written down below. That your number is always going to be kind of a little bit below and to the right of the letter, just to kind of show that it's not A times 2 and A times 1. This 11 over here then would be A sub 4, and the 8 in between would be A sub 3. Fair enough? A lot of times they're going to use A typically in this section because it stands for that arithmetic sequence or arithmetic sequence. That it's going to be, you know, just a A showing that it's one that has a constant difference getting from one number to the next. Good? Now, to get an equation or a formula like we want to write here, we need to have kind of some generic way to write this term out here somewhere. So kind of like what would be the whatever term in the sequence. We're still going to use the A typically because it's an arithmetic sequence. But we can't really put a number as a subscript because we don't know, is that the 7th term? Is that the 27th term? Is it the 2,000,000th term? Yes? But all of the numbers that we have here, going back to the very beginning part of the year, 1, 2, 3, 4. Does anybody remember what group of numbers that is? 1, 2, 3, 4, 5, 6? It's included in all real numbers, natural numbers, because natural numbers are counting numbers where like what you teach people naturally to count. 1, 2, 3, 4, 5, 6. So they'll put an N in there as the subscript. That A sub N stands for the nth term in the sequence. So A sub N equals the nth term. And I wouldn't stress about that too much, because whatever term they're talking about just depends on what n is. If n is 17, then you have A sub 17, so it's going to be the 17th number in the list, or the 17th number in the sequence. Is that fair? And having this kind of generic way to say the 17th number, the 27th number, or whatever n is, that's the term, the number that we're talking about in the sequence, allows us to write a formula. If you totally don't get this next 40 seconds, it's totally fine. You can tune me out and you'll be okay. But if you follow it, it's going to be easier to remember this formula. Let's say I want to find the 5. If I want to find this 5 degree, I take the first term and I add 3 one time. If instead I want to find the 8, I could take the first term and I could add 3 twice. If I want to find the 11, I could take the 2, the first term, and I could add 3 times. Yes? So in other words, to find any one of these numbers, I could take the first term and I could add the constant difference. How many times? Does anybody see the pattern? Not n, because otherwise it'd be like if this was the fourth term, I'd have to add 3 4 times. But to find the fourth number, I'm adding 3 3 times. To find the third number, I'm adding 3 twice. So here's what we're going to do for our equation or our formula. It's a sub n, kind of this nth term, whatever n is, whatever number we're talking about in the list, is going to equal the first term. How do I write the first term? Yep, a sub 1. And now I need to add my constant difference. I wouldn't do plus d quite yet, but I need to add my constant difference. So I'm going to leave a space for like 1, 2, 3, 4, 5 digits, but put a d over here on the end. Now, how would we write that we want to add d one less time than the number of term that we're talking about? What goes in parentheses? N minus 1. Perfect. Because now, and I don't know if I'd write this in, but under here I'm going to write, like, if I wanted to find that fourth term, a sub 4, I'm going to take the first term, which you agree is 2, and I'm going to add d, which we know is 3. Well, if I'm finding the fourth term, do you agree my n is 4? So in here I have a 4 minus 1. So in other words, find my fourth term, I take my first term, I add 3 times. One term less than the term number. You kind of see how it works? And if you kind of like, yeah, I'm really tired. We had a skating party. We had a long weekend. I have no idea what's going on. Just learn the thing in blue. The purple didn't really. How to get it is nice. It helps you remember it, but it's not pivotal to understanding it. So, good? All right. Write an explicit formula. In a perfect world, you'd know this thing in blue, this explicit formula from memory for the test. Because this is coming late in the chapter, I'm not going to ask you to write it from memory as page 1, and I'll give it to you on the test. But you're going to have to memorize it most likely. In Algebra 2, you always had to in my classes, so I'd take a stab at learning it. But if you do this in the homework, so say we want to write one of these explicit formulas, I'm going to write just kind of the generic one a second. It makes it a whole lot easier because you can just fill in stuff as you go. And by the time you would need to memorize it, you'll easily know it. So you're more likely to get stuff right, and life's going to be good. All right, so we want to write an explicit formula. So we still have to have the a sub n. We need a formula that works for the nth term, whatever that is. Fair enough? A sub 1. What's a sub 1 for this sequence there? 2. So we could put in a 2 for my a sub 1. Do we know what n is? Nope, because it depends on which term we're trying to find. So we just put in our n minus 1. Do we know what d is? 3. Perfect. So we're adding 3 every time here. Adding 3, adding 3. So we do times of 3. So this then, that bottom part there is going to be our explicit formula for the sequence. That click? Seemed like it went fast. Makes me a little nervous. All right, so if we want to find the fifth term, what do I do with my 5 if we want to find the fifth term? Exactly, you put it in for n. You agree we're trying to find a sub 5, the fifth term? And that equals 2 plus 5 minus 1. And some people just put a 4 there. I'm fine with that. I'm going to do the 5 minus 1 so I don't confuse people. But now we have our formula for finding the fifth term. We do 2 plus 5 minus 1 times 3. So it ends up being 2 plus 4 times 3. 4 times 3 is 12. So our final answer then is 14, or a sub 5, or the fifth number in my sequence, is going to be 14. Yes? And it makes sense. If you jump back up here, you could say, well, this is the fourth term. A sub 5, then I just add 3 to it, and I get my 14. And you're welcome to do it this way if you want to for smaller ones. But you're also sometimes you want to know the 20th term or the 3000th term or something like that, in which case it's way easier to use the formula. So our formula was a sub n equals 2 plus n minus 1 times 3. So if I want to find the 20th term, that's the same as saying I want to find a sub 20, which is 2 plus 20 minus 1, or 19, times 3. So 19 times 3. 57, I believe. So 57 plus 2, so 59. So my 20th term is 59. Does it make sense? Any questions we should go through together? Or?